Let's look at notes for trig unit derivatives of inverse trig functions. This section is 5.6. So if we think about inverse functions for a second here, the rules that we have to find an inverse function is we switch the x and y variables, and then we solve for our new y value. So for instance, if I want to find the inverse function for sine of x, I can first switch the x and y. So x equals sine of y, and if I want to solve for y, I got to bring the sine over to the other side, so we can use inverse sine. So when we bring a trig function to the other side of the equation, turns into arcsine of x, so y is equal to arcsine of x. So this is our inverse function for sine of x. So f inverse can either be written as arcsine of x, or f inverse can be written as sine to negative 1 of x, which is also inverse sine of x. This is the more common usage that you see with homework problems, so we're going to stick with arcsine of x. Okay. We know that a function and its inverse, they're composite. If we take the composite function of both, they're going to cancel each other out in a way, leaving you with just x. Okay, and that's the case with all inverse functions. So that's be the same case for sine and arcsine. So if I plug arcsine of x in for the x of sine of x, then sine of arcsine of x will cancel each other out to be x. Same thing, arcsine of sine of x they're also going to, in a way, cancel each other out, leaving you with x. And this works with all trig functions, right? Secant, arcsecant, cotangent, arccotangent, cosine, arccosine, so on and so forth for all trig functions that we know. Okay, let's look at some class examples. So example 1, find tangent of arcsecant of square root 2 over 2. And another way to think about this is meaning for us to find the tangent of the angle whose cosine is root 2 over 2. So first, we can focus on the triangle that's produced by arccosine of root 2 over 2. So arccosine root 2 over 2 is the same thing as saying cosine of theta is equal to root 2 over 2. So we can draw a triangle with that characteristic. Right? Theta is the angle. Root 2 over 2, this is for cosine, the trig ratio is adjacent over hypotenuse. So adjacent root 2, hypotenuse is 2. We can use Pythagorean theorem to find out the other side, and the y value here is going to be root 2. All right, this should make sense too. 45, 45, 90 triangle has this relationship here. So first step that we do is we draw the triangle and we label our angle theta. Okay, we label the sides according to the arccosine given, okay, which we did. We also used Pythagorean theorem to find the third side, root 2. So now we can find tangent of theta, right? We're trying to find the tangent of the angle whose cosine is root 2 over 2. So now we have information about the triangle. So tangent of the angle whose cosine is root 2 over 2 is simply going to be opposite over adjacent, right? Opposite over adjacent is the trig relationship for tangent. So opposite is root 2, adjacent is root 2, so root 2 over root 2 is going to be equal to 1. All right, number 2, find the cosine of arcsine of 5 over 13. In other words, find the cosine of the angle whose sine is 5 over 13. So whose sine is 5 over 13, we can draw a triangle with that characteristic. Here's our angle. Opposite over hypotenuse, so opposite is 5, hypotenuse is 13. Pythagorean theorem will allow you to get to the third side, which is 12. So now cosine of the angle whose sine is 5 over 13, cosine of this theta it will be adjacent over hypotenuse, so 12 over 13. Okay, example 3, write the expression of secant of arctangent of 3x in algebraic form. So in other words, find the secant of the angle whose tangent is 3x. So tangent of theta is 3x, so tangent of theta is 3x over 1. Opposite over adjacent, opposite is 3x, adjacent is 1. We can use Pythagorean theorem to find h. So 1 squared plus 3x quantity squared is equal to h squared. So 1 plus 9x squared equals h squared. So for h is going to be square root of 1 plus 9x squared. And that's simply going to be the hypotenuse here. Okay, so now we want to find the secant of the angle whose arctangent is 3x. So secant of the angle will just be hypotenuse over adjacent. So root 1 plus 9x squared over 1 simply be square root of 1 plus 9x squared. Okay, example 4, find the derivative of y is equal to arcsine of x. So there's two methods. I'll show you the first method, which is simply using implicit differentiation. So here are the steps. We take, based off of what the equation is, we want to take the inverse of both sides. So here arcsine, y is equal to arcsine of x, so we're going to take the sine of both sides to cancel out the right side. Okay. Second step, differentiate implicitly. Third step, solve for dy dx. And then finally, we want to rewrite the right side of the equation in terms of x. Okay, so let's go through this example here. We start off with y is equal to arcsine of x. So we take the inverse of both sides of the right side and apply it to the other side. So sine of arcsine of x, or they're going to conveniently cancel out to just be x. And if we take sine of one side, we've got to take the sine of the other side as well. So sine of y is equal to x. Okay, now we got to differentiate implicitly because now the y is mixed in, it's not explicitly stated, and it's mixed in within the trig function. So we find the derivative implicitly. Sine of y, the derivative of sine of y is cosine of y, but because we're involving y's derivative, we got to attach dy dx. X's derivative is simply 1. Okay, third step, solve for dy dx. Divide both sides by cosine of y, so 1 over cosine of y, which we can rewrite it as secant of y. Okay, but we want to rewrite the right side of the equation in terms of x, so we look at y, and we see what we can replace y with. Now y can be replaced with the original equation, arcsine of x, because y is equal to arcsine of x, and we want our equation to be in terms of x. So we're going to replace arcsine of x into y. So now our derivative is simply secant of arcsine of x. So now we can just use what we did with example 1, 2, and 3 and figure out the value. Basically, we're trying to find the secant of the angle whose sine is x. Okay. So this parentheses tells us that sine of theta is equal to x over 1. So x over 1 is opposite over hypotenuse. Opposite hypotenuse. Use Pythagorean theorem to figure out the third side. Square root of hypotenuse squared minus x squared. So now the secant of theta, secant of my angle, is just hypotenuse over adjacent. Hypotenuse is 1. Adjacent is root 1 minus x squared. So dy dx is simply 1 over square root of 1 minus x squared. Okay. This is one method of solving, which is a method that is nice to know. It's probably the method that is the easiest, simply because we can apply these 4 steps for every trig function. The problem is that it takes a little bit while longer to solve because of all the steps that are involved, but we don't have to memorize all the different trig functions derivative. The other method is memorizing trig functions derivatives. So let's look at example 4b, where we can apply that rule, those rules. So here are the derivative rules. Okay. The derivative of arcsine of u is simply u prime over square root of 1 minus u squared. And the derivative of arctangent of u is u prime over 1 plus u squared. And the derivative of arcsecant of u is simply u prime over absolute value of u times square root of u squared minus 1. Okay. I made a typo here. This is actually arc cosine of u. So arc cosine of u, sorry, other side here. Arc cosine of u is simply going to be the opposite, or the negative version of the arcsine. Arc cotangent of u is simply going to be the negative of the arctangent, and arc cosecant is simply going to be the negative of the arcsecant rule, the derivative of arcsecant rule. So let's rework problem example 4 using our derivative rule rather than using implicit differentiation. So y is equal to arcsine of x. If we want to apply the u prime over square root of 1 minus u squared, we've got to identify the u value. The u value is whatever is inside the arcsine function. In this case, it's just x. So then u prime is just the derivative of x, which is 1. And then over square root of 1 minus u squared, our u value is x. So therefore, square root of 1 minus u squared is simply square root of 1 minus x squared. It's a lot faster to apply the derivative rule, but again, the problem is all the rules to memorize are going to be more difficult to retain. So I would suggest knowing both the rules, being able to solve it implicitly, and also be able to go through it using derivative rules, which are a lot faster. And also, knowing both ways, you can use that to double check your answer with two methods to solve. Okay, next video I'll go over the rest of the examples.